Next, we move on to feature interaction creation. So df is equal to df.tree.copy. Basically, what this line of code does is it allows us to like create feature interactions without like messing up like the original data set. Then here's our like first feature, which is income to loan ratios by df.feature income to loan ratio to df.income annual divided by df.feature loan down plus 1. And then we have like the loan to income ratio of debt, which is like the debt to income ratio by df.feature loan to income ratio. And then we have the total assets, which is defined as df.total assets, which includes the registrable asset value, commercial asset value, luxury asset value, and the bank asset value. Then we have the assist to income ratio, which is given by df.features, the brackets assist to income variable, which is divided by total assets, plus like income annual plus 1. Then we have income per dependent, feature to feature is equal to income per dependent, which is equal to income annual, which is divided by a number of dependents plus 1. Then we have CIBLI score interaction with income given over here, and then we have the high CIBLI score with binary features given over here. Then we have the list of like interaction features from like income to loan ratio all the way to high CIBIL. Then we move on to for feature and interaction features. Print off feature. Basically this creates like this prints out all the 7 interaction features. So here's the 7 interaction features from income to loan ratio all the way to high CIBL. Next, we move on to visualizing key interactions by loan status by fig axis equal to plt.subplot 2, 3, and fig size is equal to 15 and a. Basically, this creates like a 2x3 grid. Then we define like the key interactions over here from income to annual ratio with the high CFL. Then we have for I feature and emergent key interaction. Was basically what this does is it basically loops through each of the features with like the index counter, and then we basically box plot it by defining df as equal to df.feature, x is loan status, y is feature, and x is equal to x is I. And then we set the title and the tick parameters, and then we plot it over here. So here's our visualization. So income to loan ratio by loan status. So approved has like a higher range as compared to like rejected, and also has like a higher medium. They both have outliers. Then we move on to loan to income ratio by loan status. Basically, approved has like a higher range and like a higher medium as compared to rejected. Then we have assets to income ratio by loan status. As approved has like a higher range from rejected, and it also has like less outliers. Then we have total assets by loan status. As the trend before, approved has a higher range and compared to rejected, who had like a lower range. Then we have a CML income interaction by loan status. People who are approved had like a higher range of CLI by interaction. Then we have a high CBL loan status, so people who had high CLL were approved as people who didn't have a high CLL who were like rejected more oftenly. So yeah. Next, we move on to feature scaling and normalization. Feature columns is equal to comma brackets loan dependence all the way to the bank assets value plus interaction features. Basically what this line of code does is we're basically preparing the features for scaling and modeling later on. X is equal to d of features brackets feature columns. Basically it specifies the specific columns from like the d of features data frame over here. Y is equal to df.features loan status encoded. Selects like the target column, so basically like the one we want to predict. Then we do x is equal to x replace parentheses brackets and p infinity and negative and p infinity with comma and p nan. Fill nan with x medium. Basically this handles any of like the infinite values and like nan values over here. Then we print out like the x dot shape for the feature matrix shape, target vector shape, y dot shape, and features to scale with length feature columns. Then we have scalars equal to originals none, standard scalar, standard scale all the way to robust scalar to robust scalar. Basically, this defines like the different this defines a different scaling method, and then here we have here's the output. So feature matrix shape is 4,269 rows and 18 columns. Target vector shape is 4,269 rows, and features to scale is 18.